Let's look at the absolute value theorem. This is a very useful theorem when we're working with limits of an, trying to figure out whether it's going to converge or not. The theorem simply says if the limit as n goes to infinity of the absolute value of an equals 0, then the limit as n goes to infinity of an must also be equal to 0. And I'll show you an example here in just a minute of why this thing's really useful. Really what this is saying is, let's just take a look at an for a second. Let's suppose, whoops, let's make that a 1. And I'll try to line these up in a decent way. Because one of my previous examples, I'm sure you saw, I didn't line these up very good, but oh well. Okay, so let's just say that an, I'm going to do an in black. So let's just suppose that an goes like this. What's happening here is an is positive and negative, positive and negative, positive and negative, positive and negative. But I think you can see I'm getting closer and closer to 0. Okay, so how about the absolute value of an? Absolute value of an would have this value, but this would be the positive of it, which would be this value. This would be the positive, this value. This would be the positive, this value. And this would be the positive, which is this value. So what this is saying is if I take the absolute value and the absolute value goes to 0, then clearly an, the original one, goes to 0. This bouncing back and forth. It settles down. So that's kind of a graphical representation of what this theorem is actually telling us. So let's do a quick example here. Let's show that the following sequence converges, and I'm going to let the sequence an be -1 to the n over 1 or times 1 over n factorial. Now see this -1, when n is even, this is a positive. When n is odd, this is a negative. So this will give me that bouncing back sort of thing. So if I simply say, hey, I want to take a look at the limit as n goes to infinity of -1 to the n times 1 over n factorial, this guy here, it can be pretty confusing. But based on that theorem, I can take the absolute value of an, and the absolute value of an equals 1 over n factorial, because the absolute value simply removes this negative component, and whatever is negative makes it positive. So really, based on that theorem, I can take a look at the limit as n goes to infinity of 1 over n factorial, which is clearly equal to 0. Therefore, -1 to the n times 1 over n factorial converges to 0. Now, just as a reminder, in case you haven't spoken factorial in a while, n factorial is equal to n times n minus 1 times n minus 2, yada, 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 down to times 1. That's the definition of a factorial.